Okay, we are recording. Okay, this is Derwin King with ELC 215 Electrical Maintenance, and this is our first night. We're at Sampson Community College, and this is for anyone that can't make it tonight or maybe out of town. McGill, I know you're going to be watching this from your hotel in Florida, so anyway, you enjoy your vacation down there, and have a safe trip back. So this is for anyone out there like you, whoever. We're going to go ahead and get started. We're going to go over our course syllabus and then get started on our materials about our equipment here. So let me do the screen share. There. So you should be seeing the screen out there. And let's get y'all some syllabus. Here. Does everybody have a syllabus? Everybody got one? Okay, good. So thanks for coming, and you'll learn a lot this semester. You'll be surprised. The further you get into it, deeper it gets, and you might need to go get your scuba diving outfit, some oxygen tanks, because it's going to go, we're going to dig on in. In the world of PLCs, networking, and programming, and troubleshooting by way of looking at programs and all this, there's a lot to it. You'll appreciate a lot. You'll learn a lot. This kind of puts together, it puts together all the skills that you've been learning in this program, your mechanical, your hydraulic, your pneumatic, your motor controls, PLCs, all this stuff goes together in this. But the emphasis is advanced PLCs. That's the emphasis. So it's kind of like a capstone class to where it sums up what you've been learning. But you'll appreciate it. It's the closest thing you're going to get to being in a plant. It's just kind of like going into a line that's been running, and all of a sudden, you're going to learn how to run it when everything's cool. And then once you learn how to read all the schematic diagrams and learn how to go online and look at the program and view the logic, then I start putting bugs in the system. That it's going to take, some time before that happens. Probably a week and a half, 2 weeks before I start bugging the system. When you can read, and I know you can read all the diagrams. You know how to go online and basically select what station and see the programming logic. At that point, then I start putting some bugs in for you, and you have a good time with it. You really will. People kind of get hooked on it, and it's very beneficial for anybody in plants. It's got, Patrick, where you're at. This will help you a lot. It will. Anybody that's around automation, you'll appreciate it a lot. So. It's called electrical maintenance, and I actually wanted to call this class like an automation class, but they didn't let me name it what I wanted to. But I am in the process of getting it changed anyway now, because Barney is interested in, like I am interested in the whole thing going more automation as far as the program. We got an electrical systems degree now, and I'll start in the fall. They've asked me to go completely electrical in the fall, teaching stuff in that degree. Carla Collins got a job somewhere else, so the electrical that she's doing, I'll be picking up, and then the electrical that Jake's doing, he's doing completely heating and air. He'll have first year, second year HVAC students, and I'll be doing the electrical in that program, as far as I know, all of it. And so will be, and I want it to go more toward automation, and so that's, Barney, he agrees with that too. The solar electric stuff, before they got 2 classes, they're going to get rid of one of them and let me do an advanced PLC class. And I started developing. I need to finish developing it and have a ELC 228 advanced PLCs and have drives and stuff in there with it. And so anyhow, so it's basically it's electrical maintenance for automation systems is basically what it is. I took a standardized class that was shown to me on a course outline and sort of tailored it to the equipment that was bought for this. They bought the equipment to have a new class, and so this course number was picked, and this was the equipment, so I got it pretty much. I souped up that outline. I souped it up for automation. That's my office hours, my direct office number, cell number. If I'm not in my office, you can call the cell number. And this is the COVID information right here. The main thing is that you make sure that everybody get an email from the college that was talking about self-reporting yourself if you get COVID. If you haven't checked your emails, go in there and look, and you should have one from the school from Anna Blair Hager. And let me show you the email so you can make good and sure that you know how to get this link. Because if you end up, I hope nobody gets it, but if you did, you go to this particular email, give a link, and you got to fill a form out, and then they're going to talk, they're going to communicate with you until you're clear to come back. And another one will be able to come back. So let's go to our email. Let's see here. I got the switch. I'm going to cut the screen share off and switch screens here. And let me get my share screen. There. I have to resynchronize every time I change screens. If I don't, the person watching won't be able to see. So, but all you got to do, go in and search under Anna Blair Hair in your emails, and it'll say self-reporting, Anna Blair Hair. She's the vice president of the college now. Miss, what's her name? Wanda Capps has retired. Now, so when you get that email, read through it completely, and right here, there's a self-reporting form that if you get COVID, you click that, and it takes you to a form that you fill out. You do that, and then there'll be a COVID team that will contact you. What happened here? Let's go back. And let's see. Down here, before you come back, you got to do a return form here. So you'll fill that out. Self-certification for returning to campus. You go through all of that and answer the questions. But make good and sure that you don't come back until you complete that. If you happen to, I hope nobody gets it. The vaccines are in Sampson County, and so hopefully everybody will be getting them before too long. I hope so. They've already asked us who wants to get them on for instructors. I put my name on the list. So they're great man. Well, it's like a lot of things, there's risk in everything. There's more risk in not doing it, I think, you know. Yeah. Well, they went through a lot of tests, and look at how many thousands of people died while they tested it. If they were in a hurry to give it out, they would have given it out. They'd have took a risk on giving it out, you know what I mean, early. But they're scared to do that. They don't want to end up in trouble with thousands of people dying. So that's, you know what I mean. Could you picture being someone that's developing a medicine, and while you're developing it and testing it, people are dying every day, and you keep saying, "I'm not ready to release it yet," you know. Be hard to, it'd be tough on your conscience, you know. But anyway, so let's go back to our syllabus. Well, wait a minute, what happened there? Email. Okay, so for this class, our description would be, it introduces the theory of maintenance and the skills necessary to maintain electrical equipment found in industrial and commercial facilities, but really it's the emphasis on industrial. I may include a little bit of commercial, but it's not going to be much. Maintenance theory, predictive and preventive maintenance, electrical equipment operation and maintenance, maintenance documentation. You should be able to perform maintenance on electrical equipment in industrial and commercial facilities. Demonstrate safe practices with tools and materials and industry equipment covered in the course. Understanding the technologies included on this system here. This is the SMC FMS Flexible Manufacturing System 200. Understanding these technologies, which includes electrical control panels, sensors, electric motors, programmable controllers, industrial communications with Ethernet, pneumatic, hydraulic, vacuum, manipulators, conveyor belts, and to be proficient in these skill sets, setting up equipment, operating the equipment. You know, one thing that the plant I worked in, they discovered toward the last few years before they shut down, is that it worked out better when you hire a maintenance person to don't put them straight in maintenance. When you get a maintenance person, you put them with an operator in each department for at least a day, or at least a few hours. And you go take that person through that plant, they're going to be plant wide. You put them with an operator in this line at least for a few hours. Let them see how to load the machine, how to unload it, how to understand it, where do you hit the start button, where's the e-stops, you know, all that stuff. How to do a complete shutdown, how to start it at the moment. You need to be a good operator before you can be a good maintenance person. If you don't know, and you need to just sit there and watch the machine when it's running good. I mean, you're going to do that here. You're going to, once you learn how to turn it on, you're going to watch. We're going to discuss in slow motion the motions, the sequences of actions that happen here. 1, 2, 3, 4, every little thing that it does, and you're going to learn that really well. And then once you do, then we can talk about troubleshooting. You know what I mean? But for so many years where I worked at, they'd hire somebody and throw them out there like throwing them out there to the wolves, you know, and then, you know, sink or swim, you know, and that's not good.
That's everywhere. That's almost everywhere.
Some guys can handle it, some can't. Depends on how much industrial experience you got. If you're brand new in a plant, man, that ain't no good. And that's not a true judge on how good a person is. You know what I mean? It's just not a good way to judge if somebody, you know, can they handle it? Are you going to keep them or not? So you're going to learn how to run it. You're going to be an operator first. You know, it won't take long. And but if you know how something goes when it's going good, then when it's not going good, you can examine it and figure out, well, you know, you would say, well, I know after it does this, then it's all supposed to come over the gripper. It's supposed to get there and go over. But when the arm comes over, the gripper doesn't open. So you know what's supposed to happen next. But if this, you say, well, I know what's supposed to happen next. And then you can reason out and you can hone in on the problem, you know what I mean? By knowing the whole sequence when everything's good. So that's the step one, is knowing how does the whole thing run in detail when it's going good. You know, and then, you know, you can be a good troubleshooter from that point. Then it's a matter of learning how to read the schematics, learn how to use the laptop to go in and view the logic, and then search through the program and find the reason why the machine would stop where it did. Why is it hung up and all that. So but those skills is what sets you up good to be in any plant. I don't care where it is. Learning that in general is going to help you. I don't care where you go, what the machine's doing. It ain't got to be this. It can be any kind of automation. And the idea of what we're saying is the same everywhere. Everywhere you go, that kind of a way of thinking applies everywhere. When you've got automatic equipment running. Somebody's. That's Victor. Notice it's 6 o'clock. He was thinking it was 6 o'clock. Victor's on the way. Okay. Not a problem. Okay, so setting up equipment, operating it, understanding technical documentation such as the user manual. I'm going to give you a user manual first that gives an overview of the whole system, and it gives you also troubleshooting guide at the back of it that gives you some good troubleshooting tables. And if you get stumped, if I put a bug in, you know, instead of a week and a half, 2 weeks, you get stumped and don't know where to start, pull out the user manual and you look for that section and that station in there, station 2, for instance, and you flip through the problems that it gives, possible causes, solutions, and all that, and it's a good resource to have. You might not need it. You may have such a knack for this that you may never even pull. You may never use a user manual. But I'm giving it to you. You can have it. You know, and if you need it, use it because it is good. It is good. Common sense will take you a long way with this to a point, but when you get to really getting to the root of the problem, you got to have a meter. In a lot of cases, you got to have a meter, and you're going to need the laptop also in some cases. So, but using the user manual, the practice manual, flow charts, I'll give you flow charts that show a good block diagram view of each station, of what happens first, second, third, and the conditions that each step has to have before it happens. You know, so when you hit start button, what happens first? This filter goes out. What's next? Well, the second step is conditional on something being true. That happens in the first step, right? The first step has to be completed, and then the second step can happen. So all that stuff is shown in the flow chart, or what they call a graph set. This system was built in Spain, and so some of the terms that they use are European or French terms. That over here we call it a flow chart, they call it a graph set. And you're going to get really good at reading electrical schematics. And you're going to read the international, the IEC schematics, the international symbols, not the US symbols. Now, the international symbols they're all over the US because of equipment that comes from Europe and it comes from other places. So if you go to Smithfield or Boulevard or something like that, most any place you go to, they're buying equipment from Europe. Some of this stuff you can't nobody's making it here. Some of the stuff is not made here, and they have to buy from overseas. So as Americans, we have to know the US symbols, which is the NEMA symbols that you learn in motor controls. You got to learn the IEC symbols and the international. And if you learn both of those, you can read any kind of diagram, no matter where the machine comes from in the world. You can read any of it and all of it. I've never seen a schematic I couldn't read, you know, because all of them come out of one or two symbol systems. It's either you know, US NEMA or international IEC. You'll get really good at reading PLC programs. Now, you're not going to have to create the programs in here. They've already been written. But they're sophisticated programs to run these things. If you're going to learn, you get into this, it's like going from over there, those trainers on the wall. If you took the ELC 128, it's like going from a fish pond to the ocean. It's what it's like in programming. That programming was small. It was small. It's like being, I mean, it was good. You learned a lot. The instructions you did in there, those same instructions is used in here, but there's just more of it. There's a lot more lines. And you're actually seeing it, instead of just turning on lights or fans over there, it's actually running cylinders and grippers, and it's doing a lot of stuff. And so you get to see it on the second level, which is good. You're going to be dealing with pneumatics, vacuum, hydraulic diagrams. So it's not just electrical diagrams. You're going to be looking at the pneumatic and hydraulic diagrams as well. Like in HYD 110 class, I'll give you diagrams in here that shows you the valves and shows you the cylinders. So we got schematics in here that's purely fluid power that I'll give you as well. But we're focusing on electrical, but you get the fluid power diagrams too. You need to get you a 2-inch ring binder. So get you a notebook, kind of like what Joel's got there. Get you a 2-inch ring binder, and I'll be printing all the materials. And I went to the bookstore, and they let me get some dividers today. So I did get dividers. And if you want some of these color ones, you can have them. I will give you a set of these, and you got to buy your own ring binder, and I will print all the materials, and you'll put them in there. You'll set dividers up, one for your user manual, and then the other one's for your 6 stations here. And so each time I give you a lab paper to deal with a station or a schematic, you'll organize it, and then when it comes time when I give you a lab to do, you'll flip to that section, and you will pull out your schematics, and you'll have everything there in an organized way. So let me go ahead and give you your dividers. You'll be troubleshooting electrical control panels, PLCs, Ethernet communications, pneumatics, vacuum, hydraulic, manipulator, conveyor belts by using a multimeter and laptop to troubleshoot PLC problems and Ethernet network problems. You just get the ring binder, and that's it. And I print everything from SMC and Allen Bradley and different manufacturers. You're getting a 100% manufacturers' literature and lab papers. All of it was come up with by SMC and Allen Bradley and whoever made the piece of equipment. They sent me a ton of folders to print from, and that's what I print from. So it's all high quality stuff. It's good material. You need safety glasses like always. And they got the extra big ones like I use at Lowe's if you got prescription glasses. They got the big ones and the bit over like that if you need them. Bookstores got the regular ones. The rules, everybody in here knows what the rules are. There's no sense in me going over all that stuff. You know about 85%, you know about all that stuff, about cheating, you know about all that stuff. Withdrawal, you know about all that. I don't need to talk about all that. About dangers, threats, and things, kind of report anything dangerous you see going on. We can get our campus police on top of it. Same thing with drinks, just have you a spill-proof top, 10-point grading scale. Now, the weights are different in this class. I set it up that way because it's mostly labs, so it's 65% labs, and then 20% tests, quizzes, participation, safety. So it's way different than what you're used to. Once you learn how to read the diagrams and how to use a computer to troubleshoot, use a meter, then it's going to be troubleshooting the rest of the semester. It's going to take about 2 weeks to get that one. Right at 2 weeks for you to even know how to read it on and begin running and going with it. And then from that point, the troubleshoot, I give you a work order, at least 1 or 2 work orders a night. You come in and I'll have a bug I put in every station. And I'll give you a paper. You can take a teeny thing, if there's 6 stations in you can figure out how you get to it. I'll give you a work order, and it's going to say station 2, and then from that point, you're going to try to run it. You'll put down what the symptom is, and then once you think you've got to the root, you're going to put down what do you think's wrong, and then you'll use a multimeter and a schematic to show me what do you think's wrong, and you'll also use the laptop. So I want you to show me with a meter, the schematic, and then the laptop. What do you think's wrong? And then if you've hit the nail on the head, I say, yeah, then I remove the bugs we run the machine, and then I sign off on your work order, and then you put at the bottom the tools and the ways you went about finding that problem, and you describe it was input 2 or it was output 4, it was not working right, or the sensor was not working right, and you put that stuff down, you know, and then you turn that in. And that's what most of your work is going to be doing, work orders. Like just exactly like being in a plant somewhere. It's the same exact thing. So it's a good, again, it's a good experience to get into the practice of doing that. Right here, make good and sure that you take you a picture of this. If you know how sometimes, and it happens more than one time in a semester, you can't, when you try to log on to our website, you can't get in, or you can't get in Moodle, can't get in the email. This is how you get straight to them without coming through the campus server. So to get the Moodle, you go straight to there, and it gets you straight to the Moodle provider without going through our website. And then to get your email, you go straight here. See, both of those, none of that stuff is really posted on campus anymore. It's hosted off-site. And so if you need to get to it directly, that's how you can do it. That'll get you there when we have bad weather, and when they're working on the system here, when they're servicing the server. Sometimes on the weekends, you know, they're working on it. They'll have to take it out to do whatever, to do maintenance on it. And so that's the time, and they might not even tell us. They might not tell us to get ready to shut down. Or they may send an email out and tell you, and then maybe we get checked email, right? So stuff like that happens. Okay. So that wraps up the syllabus. Any questions? So at this point, if you will, where's if you go back to the welcome mat, let me resync this thing here. And I bet I was. I don't even know if I was sharing the screen right then or not. Maybe I won't. Darn. Got it wing now. Okay, so you go back to your welcome mat and go down to your acknowledgement quiz. I would like you to go ahead and do the quiz now. It ain't but one question. So you click it. And it's only one question. I have read and understand this syllabus. Click it, hit submit. If you don't do it within so many days, it's gonna bump you out of the class. You don't, so go ahead and do it on your phone, and you'll have it done. And so once we get started with the semester, it's gonna be hard to remember this stuff. So I wouldn't cut it off. Is everybody able to get to that? If everybody got access to it? Okay. This is a good time to make sure that you can get in Moodle. While you're doing that, the user manual I'm getting ready to give you, I'm gonna go ahead and upload that from McGill. Let's see. For anybody that, let's see who. What's the roll call here? Find out who. Yeah, Victor's on the way. So that's 3. Okay, let's go A. Uh-oh. Ooh, I didn't want to do that. Uh-oh. Nope. Nope. Ouch. Go back out of that. Let's go here. Let's go. Hey, buddy. Yeah. There's your syllabus. There's none on there. You go to school by closing yourself before. Oh, good. Just check that. Let me show you the number on there. It's a phone number. You have to have an issue with it. You can't even have Hannah right there. So if you happen to get it, you click that block over, and then let's say when you come back, you go out and this is just something that I hope I don't get you. Somebody be. I came back to make it. Yeah. Make that good for it. So you have experience. Yes. Yes. It's 75. It gives you about 2 inch ring around. You put the wires in, you put that section. You can buy a book. I can't run it out. You don't feel like it's good. You can look at the full you want to set up here and do this stuff. I'm recording from a deal. If you can go ahead on your phone, yeah, and get in Moodle and do your syllabus acknowledgement question. Click it. No. I've got it outside the zip now, so I can do. Didn't want the. Okay, let's go here. There it went. I had to get it outside the zip file. It's trying to upload the whole zip file. Okay, so I got the user manual up there for McGill. And let's see, go back. So you can view this on your phone or wherever. It's a yep. 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 That's it. I'm gonna give y'all a copy of it. I just put that on in Moodle that he can see it from down there, or anybody that ain't here can see it. Okay, I'll give you a paper copy of it. It's a whopper. It's a very thick document. So I got it home. So that'll be your first thing in the notebook. Oh, sir, that's just to use a manual. That's just to get your feet wet a little bit. Yeah, I'm telling you, you better go buy some scuba diving equipment, man. I'm telling you. Oxygen tanks and everything, man. I ain't kidding. We're not going to go through the whole. I'm just going to kind of show you the advantage of using it. You don't have to read the whole thing. The main thing is kind of knowing. It's kind of like the electric code book. I don't read the whole code book. I read the parts I need to read. I read the parts of the code book that's pertaining to what I'm dealing with. You know what I mean? Nobody has time to read the whole thing. So when you go through each station, there's 6 stations here. The first one is 201 base feeding station. The next station is 202 bearing insertion. Hydraulic press is the next one, 203 and so on. 204 shaft insertion. 205 cover insertion. And 206 would be screw insertion. Now, we don't have 207, 208 and so on. I put a request in to get the next station as a servo station that will get the end product and put it in a little warehouse thing to servo control. So we're waiting on the approval to get that, and when we get it, I'll be able to teach you servos, how programming and troubleshooting servos and how to wire them, which is it's motors that have any coders on the back of it, pulse coders are sent. As the motor moves, pulses are being sent back to the controller. The controller knows exactly where the motor is, how fast it's going. So it's getting tachometer information, speed, and it's getting positional information from the motor constantly from the motor with a servo. So it's a motor. It's the ultimate motor that they use them on robots. Robots use servo motors on robots. So every joint on a robot has a servo motor, and like with your body, the elbow and the neck and everything, on a robot, every little joint's got a servo motor on it with pulses being fed back to the control, so the control knows where every joint is at one particular time. And you can control the destination of a motion real precise, so that's kind of one thing that we're, a next step for what we'll be heading to here toward robotics would be servos. And so I've got quotes, and I think it's coming. It's just a matter of time. We've got more access to money again. I've been told that there's a pot of money that we might get it, and I hope that we do. I think we will at some point, and that'll be added on. So, but see, there's other stations that we didn't get the money was there. But, we'll add to it. So I'll show you what you're seeing with each station here, and then we'll get on to doing a lab here. So it's showing you there's more stations there than what we have. It tells you what each station does. And it shows you the components that get assembled. The body, the bearing, the shaft, cover, screws, and all. Giving you an overview of what's there. Now, then it takes the first station. That's one station. And it goes over the details of the station. Now, so for if you may not even use this, but if you get stuck, pull it out and use it, okay? Because it may get you thinking, but where you may get stuck on something. Y'all get stuck sometimes. We have problems. We just admit it. We get stuck sometimes. I don't know. I'm just hung up. Don't know. I don't have a clue. So for station 1, it tells you, it describes mechanically what it does. Then it goes into the parts that are used. It's telling you in detail what it does. pictures of the devices that it's describing. And it's giving you some technical information about that one station. It's even giving you the part number for the cylinders, double acting cylinder with flow regulators controlled by a 5/2 solenoid valve, the sensors, the magnetic read sensors, inductive sensor detectors giving you part numbers on the sensors that are on the machine. It's giving you the details on all of your actuators, your pneumatic cylinders, sensors, and everything. So it's giving you all that stuff, a lot of detail, and some information about the control panel. And then it moves into the second stage. So you're getting some technical information. Let's go down to the end of the whole manual where the troubleshooting is. And I just show you what you can, it's there to use it if you want to use it. So your troubleshooting guide will be in here. Now, remember that when you get beyond station 6, we don't have it. So, so for troubleshooting, here at the back of the book, that's what I just gave you for station 1. Symptom: the station does not start after pressing the start button. Well, possible cause: the station might be disconnected or the room has no voltage. And then you could check, here. Maybe the emergency stop has been pressed. Then release it and press reset. Maybe the air intake is not connected or the air valve is open. So check your air supply. The isolator or maybe the main switch is open, The switch in the breakdown box causing the fault is actuator. So what's the breakdown box? Breakdown box, each station has a fault box that I can open up and flip a switch, 1 out of 16 switches, and it's going to produce a problem. And that's part of what I use. If you guys come around, well, actually I can do it over there. You can see easy. I come around your way and do what you can see. So fault box, if you look right here, then each station has one. And you see the switches that are in there? Come around to the switch. I can go in here and flip a switch, close that thing up, and it's going to run to a certain point. It's going to be a problem. It's going to be just like a real problem. It's going to be something to observe. So it's a way to make it really quickly insert a load to each one of the machines very fast. And I can remove it very fast like this. And then the problem comes. So that's the fault box. So if you get the button and it doesn't run, then it may be what I do. It may be what I do. And that's what's really off there. So that's interstation panel. That's one of the boxes. And that's how we get started from. Because what will happen is you get so good at that, you know, my wheels, and then I have to stand it up. I start doing other stuff other than the problem. So, it doesn't take long to get so good at it. You'll be knocked out. You'll be saying, what's next? And I'll say, okay, you said, I'm going to go now. I'm going to put something else in there and a little harder. So, anyway, it'll get good. It'll get real good. You want to hear the switches in there? I go over there, put a switch like that, close it up, and all of a sudden it's not flowing. It might be 3/4 way to the switch, but you can sit there and play. That's going to be a real problem. Yes, sir. Yeah. So, I can switch it up again. And I never run out of bugs like a present. I never run out of presents to give. Sound false. When you find it, if you unravel and find it, then you learn something. So if it is correct. Every time you get to the root of the problem, you're sharpening your skill. You know what I mean? You're sharpening your troubleshooting skills. And I'll switch it up. It'll be one thing this time, something else the next time. It's going to be like curveballs. You know, it's going to be. It's good. You'll like it. You'll learn a lot of stuff. It'll be random. You'll be on here one time, over there next time, over there next time. It's going to be something different every time. So it's good. The sharpening up of your thinking skills. The cell is not connected or the transfer air valve is open. So that's just ideas whenever it does. The station does not start after pressing the start button and the fault LED flashes on the keypad. So here's what it can mean most likely. The station is not in the initial conditions, which could mean this. That machine, everything didn't go home the last time it was stopped. Okay, somebody could have killed the e-stop in the middle of a cycle, and everything. In other words, you didn't let it finish. So it was in the middle of something, and a cylinder went home, and somebody killed the power, and then we went home. So you come back, start it up, and it ain't home, and so the PLC knows it ain't home. So then the fault light comes on. So that's another possibility right there. It checks initial conditions. Every station, the first thing the PLC does is it checks every sensor on there has to be in one or two positions, either extended or home. And the overall scheme of being home, there's a setup, there's a run in there, a long run until it sets up. All the conditions in series have to be true for it to say it's home and you got permission to run. And if it ain't true, you get a fault. So I can go in there and flip one switch and the initial conditions will not be met and that fault light's going to flash. And you got to figure out which initial condition is it, you know? And there's a lot of sensors, you know what I mean? So you got to figure out which thing is not home or which thing does it think is not home. Maybe it is home, but the sensor does it say it's home, you know? So stuff like that, that's kind of things that it could be. When you see the fault light flashing, that's a possibility. The station does not start after pressing the start button and the table LED flashes. There's a table LED that's like a stack light, and then there's a fault LED on the panel. So the stack light, if it flashes, it means that you're out of material that this machine uses. So if this station uses bearings, that means if the stack light comes on, it's out of there. It ain't got no bearings. It went forward and there won't be no parts in there. So it's out of parts. So that means the operator's got to reload. So you get the idea? So that's just your starting things that you would look for. It says the material feeder is empty or the material feeder is clogged. So maybe the parts are there, but maybe they got jammed and they're not feeding through the hopper. You know what I mean? So then they can't feed down to the sensor that says that you got parts. So that's another possibility there. Anyway, you read on through the guide. The station starts. However, it after a short time it stops. There might not be enough air reaching the actuators. Maybe the room air does not meet the minimum requirements. Now sometimes that happens, seriously. I'm going to tell you how it can happen. Somebody can come, and you can watch it. Well, it probably won't happen at night, but in the daytime it happens. We be in here running. Somebody in that transfer room in another class, they get tired of hearing the air compressor run because it's running over the top of that room. And they don't think about us in here. So they go outside and they cut their compressor off, and we don't know it. And then slowly the air dies. And everything in here goes, like that, you know, and then we end up with everything's fouled up because the air is getting low. So at the plant, the air compressor does die, right? It does. And everything, huh? Yeah, everything goes in a long, slow motion, and then everything shuts off, and all your operators are hollering. An actuator is moving at an excessive speed. Your flow regulators are set at a minimum, which means, you know, you need to regulate the flow. You got needle valves on your cylinder, these little old plastic needle valves. So if you got something slamming, you got to slow your airflow down on the cylinder. Okay. If it's creeping too slow, you got to open up your needle valves because maybe somebody moved it by accident. You know, things like that. So most of the problems I give you will be electrical, they'll be control wise, but then sometimes I'm gonna slip in something like that. Then you'll be expecting another electrical problem, but it's gonna be something like that. Right? So it kind of beats me, keep a broad view because I keep it interesting. I guarantee you, I'll be watching you when you get real good at a certain amount. Whoop, I'll switch gears on you. The station always stops when reaching the same point. Now, it can be a switch in the breakdown box, and I'm notorious for that. But it can be a detector that's faulty, a sensor. In real life, one sensor can be bad, and this thing is going to get to the same exact point and sit there and just look at you. Just go, blow, you know. And it's sitting there waiting for some signal that it didn't get, right? So that's a real thing. Could be a solenoid valve that's faulty. Very real. Now, it may be a sensor, but it might be a valve. Maybe the PLC told the valve to trigger, and it did not switch air, and it did not move the cylinder. So it may not be the sensor. It may be a valve. That's another one. This is really good. This is the way it is. This is real life. This is the way it really goes. That's why I have a system, a real working system. You're not narrowed into just control, but you look at the whole thing the way it's going to be when you step out there, right? Because it ain't always going to be electric, you know. It ain't always going to be mechanical. But you want to be a multi-craft technician that knows the entire system inside and out. And you will. You're going to know this thing inside out, left, right, upside down. You're going to know it inside and out. Guarantee you. If you just stick with it, you're going to know way more about this thing than you realize. You get done with it. And it sets you up to go in any plant you want to and tackle a line. As long as you got documentation, you can go in there and tackle a lot of stuff that you might not tackle now. You know, just getting into the swing of it with this system. Incorrect positioning of a part being mounted by one of the station components. So something did not get positioned correctly when it moved. You might have a detector or a sensor faulty. Your holding means could be loose. In other words, a gripper could be loose, a cylinder could be loose. You may have something misadjusted on the station, and so on, things like that. So again, the troubleshooting guide is good. It's at the end of your user manual. So yes, again, I would use it. It's going to open you up when you get stumped. If you get stumped, I mean, most of us get stumped. It will help you get unstuck. And that's just station one. The suction cups do not have the required force to pick up the part. Station air regulator might not be set properly, and it's telling you what to set it for. So instead of being pounds per square inch, it's in kilograms per meter, cubic meter. So that's the meter square. That's cubic. It's actually square on this. So anyway, everybody get the idea? And then it goes into station two. The station two is, there's similarities, but then there's things that are unique on every one of them. Here it's got roto linear stuff that one does not have. It's got sensors that one doesn't have. And so, you know, but it's, your guides are particular, you know, they're particular to the station. So it does pay to read, you know, just kind of know where to go in the book, in the literature, know where to go to get information if you need it. That's the main thing. You know what I'm saying? I got a code book, and if when I use it, I just go specifically to what I need, and then I don't touch it till I need it again. You know what I mean? Okay, everybody got it. So it's pretty good. It's a good starting point there. And then, any questions? All right, let's get out of that. And so now I'll give you your first regular lab, which is on station 1. And we do this together. We do it together. Actually, let's just start out and run. Let's just start out and run the system. Let's watch it in slow motion, and let's run it. Let's run it in slow motion. Let you get familiar with the way the line looks when everything's good. Okay, let's just do that to start. Get this shit out of the way. Now, here's what I want y'all help me remember this. I've got these gloves. Let's everybody wear the gloves so that we're not taking a chance on spraying germs, but everybody handles the buttons and stuff, the switches and all. Everybody okay with that? I got extra large. I got all them at Lowe's. Okay, so I mean, the school doesn't provide this stuff, and I'm going to have to provide it. Y'all need extra large. Can you get some gloves that will fit you? Can you get just get your pair of? I do the move. You have some thin gloves you can get. I ain't doing it in a while. That's a move. I ain't upgraded in a while. No, it's for doing it too in the beginning. Mine never did, thank God. It's the biggest ones they had at Lowe's. I mean, they ain't got nothing no bigger than that. Got two. I tried LGs. I never went to the motor. I tried to the motors were stepping up now. Now I'm gonna say this. Let's kind of look out for each other. If you see me not with no gloves on, then say, hey, what's good for the goose is good for the gander, right? What to say? Whatever old saying. So I think they'll fit. Did you get them on, Luke? Look at that, man. I spent $20 on that box of gloves to get something big enough to you. I ain't kidding you, man. I think it was $20. It's close to it. Yeah. I'm gonna try to slip an order in to order some, but in general they told me they don't supply this stuff, and I don't care. I'm buying it anyway. My goal is to get through this thing successfully. Nobody's sick, and if it costs me in my pocket, that's fine. I don't care. I got a bonus anyway, and I got $800 from the government, so I think I can afford a $20 box of gloves. You know. Okay, so if you go to each station, and there's a switch. In the emergency stop, there's a switch, the second switch. Beside the red button, just cut it on. And it's going to take a few minutes for the machines, for each one of them to boot up. Once they boot up, you'll hear the conveyor come on. The PLCs have to boot up their program, and when they do, the very first thing they do is it turns the conveyors on automatically. Now put all of them in manual. So go to manual, it's auto manual switch, go to manual. So we can see if each station run in what we call step-by-step mode. You put it in manual, each time you hit the start button, it's going to execute one move and just wait. And it gets happened again, it does the next move. It's happened again, it does the next move. It's a way to execute the program. We're going to do the first station first. You got to get, somebody get around this side. We're going to watch this station first. And we all have to kind of move around the and so over here where the completed part are, we got a disassembly and lays the pack back over here. We'll take the screws out, we're going to put the screws back in the screw station, and we'll put the parts back underneath it. The bodies here, they've been poured out. So the bodies have to be placed in there so the board up. Put them that way, it will detect it. It'll actually kick down the shoot its nose with a plunger detector. When it goes in, check the upside down. That sensor will make it take off the down. So you can mix them, and it'll kick the balance out if it wants to do it. I'm going to flip this. I'll do one at a time. The screws go in with the head up, Yeah, head up, yeah. If you flip them upside down, it will jam, and then the next time, I'll show you how to understand it. And it will just sit there and roll, you put it upside down, and we fire off, right here. These shafts, they go in. You can put them upside down, it doesn't matter, it'll actually straighten them out. There's a split device over there. These, you can. And right now, it does all the covers, it does the same between the so it doesn't matter how you put them in. You can put them with the rim up. Put them with the rim up, or it'll actually jam at the bottom. And that's not a big deal. And when you're hitting, if you don't put anything in it, it stresses what gets put in here. It stresses the part.
I was making sure.
Now, so the pallet, they got valve pins in them, and it doesn't matter how you put it in there. These screws are actually codes that would be used if we had a warehouse set, and the code would represent a certain product. It would be a certain bearing. There's a low bearing and a high bearing, and then There's two kinds of shafts, there's 6 kinds of covers. So depending on what product you pick, you can be protected in both patterns. And then these sensors with bullet, these that we're putting in the warehouse, based on that, we don't have all these spaces, so we don't use the pattern recognition on those sensors. It's there, but we don't have that, so it doesn't make a difference what happens. It doesn't matter. So now, you get the flashing light there, I'm gonna let somebody hit the reset button. Now, when you hit the start button the first time when you're in manual, you hear the earphone. So the first step into the PLC program, whatever day we did, you did it with logic. You did it the first time you did it, it cuts on the air valve up inside. That's a master dump valve that opens up and lets air into the whole system. So if somebody gets greased off over here and it dumps the air, it's going to kill everything in it. Just remember that. Sometimes that'll happen. Sometimes that doesn't happen. So if you end up losing air, it may be right here. Or it could be the air regulator, the dump valve, is a blue dump valve manual. Each one, if it gets triggered like that, then the air is dumped just for this space alone. But that's a manual dump valve. So just kind of keep that in mind as far as air. The electric dump valve for the whole system is based on this. So hit start button again as soon as there's step 2 of the system. So what it's done here is it's execute the first action, which the PLC is looking for the button. When you're in manual, it takes the button every time. When you're in automatic, you hit the button one time and it gets the step. But it went forward, and so what you got to keep in mind here with all your automation systems is that when it gets some input it's looking for, then it says, okay, that means I can do my first step. The first step is it brings the bottom out. When it does, there's 2 sensors on here. This sensor lights up when the cylinder is forward. This sensor lights up when the cylinder is back. So you have extension of a traction sensor that the PLC monitors that tells it, those are the eyeballs that say it, we can look up and see where the cylinder goes on, right? And you see, look at the red lights on there, y'all get around and look at it, make sure you see those. See the LED? So most sensors have LEDs on, so you can do a lot of troubleshooting just looking at LEDs as far as is the sensor is it being activated? So what turns it on is this is an aluminum barrel on the cylinder. Inside of it there's a magnetic ring that goes with the O-ring of the piston. So when the piston moves, there's not only an O-ring, but there's a magnetic ring that floats to the piston. So there's a moving magnet in there. When the magnet moves near this sensor, then the sensor lights up. It senses a magnetic ring inside it. It's a magnetic read sensor. So most of the cylinders on automation, no matter where you go, what plant. A lot of them use the built-in sensors that plant right to it that lead you to this. So you got to set the machine up. You send the cylinder out, and then you adjust this. You lock it in where it's lit. When it gets instructed, when you bring it home, you adjust this one so it knows when it's home. And then the program is written to check position before it does the next thing. You know what I'm saying? That this is the stuff that you can look for all of these machines so that it is. So the next thing that happened was this. You brought the body forward, and then you brought the plunger down. The plunger is checking inside there. That plunger went, and it went down into that hole to find out could it get in there. And if it couldn't, that means that the block was upside down and it's not correct, not placed there correct. But it actually did get down in there to go and look, and there's a sensor come on, right? Sensor sees it, so it told the PLC the block is positioned correctly. So it knows that when it gets over here to load it, to go ahead and load it and don't put it down the bridge. Do you understand? So go around and make sure you can see that. So there's a lot of confirmation steps that happen with these sensors that for every action, if it's something else is supposed to happen to say, it completed that. You know what I mean? And the sensors, what tells it is what tells the controller. You know, the controller says move, and then the controller says do move. The sensor says, yeah, I made it all the way there. It's like if I call the deal, if I send the deal a text, if you get the log, yes, I do. That's the sensor. You get in the stroke, he's in Miami, right? So he sent your signal back, you know, it's just like this here. Like, I know to do the next step, you know what I mean? That's the way this stuff runs. You know, there's a series do something, and then check and see if it's safe to do the next one. That's the way the automation runs, don't worry about that. And here's it again, you'll see that plunger go up. So here's again. Watch behind her when you get it. See it come up? It's nothing but a rubber plunger, but with the plunger comes the cylinder has a sink on the backside. It picks up the ring on the piston, so the piston goes, it knows that the piston makes it down. So, yeah. All right, do it again. So then it came home, okay? And then it gets here with it. See it's in there with it now? So the back is with it now. See there? That's how the system works. If they know where things are, what he said. To see another cylinder move around. See, the other sensor knows that one made it, so it told the controller after it completed the action. But sometimes it's not guaranteed to get there, right? There could be another box sitting up there where maybe a previous step didn't get cleared out. It could be. I think it was just sitting there pushing against it. What happened is it's been sitting there, a lot of that pressure on it. And you go to the careful, you approach this thing, don't go in the cash. There ain't no doors around it, right? You could have sitting there with full air pressure on it, trying to get it in the stroke, but it can't because it's too far from it, right? So, think before you step in, don't put your bare hands in there for no reason whatsoever. Let's say if there's two of these in there like that, you just need to get to each spot and make sure that the air dumps out, the air is totally released, get the power down, lay it down, and then you can even go in here and move these and make sure the air is everything loose, no pressure, and then you can go and get it out. You know, be careful. Right? So you can step in. Okay, so on this one, those of you on this side, what do you see on this side? Right. So if you come around this side, there's a retraction and extended reed sensor. And so they know if it's bound for stuff. So that's just looking for that. See, I can see the bottom. Yeah, you can. Yeah, you get the mirror to the light. Yeah. And so when it's down, that one's good. You come up to here. The vacuum came off. The vacuum generator right here, it shoots air. The B plus valve, if you want all the B plus valve comes on, PLC turns it on. it shoots air pressure in the vacuum generator, and it makes vacuum out of air. It goes reversal. So it's not a vacuum pump. Comes up, and the sensor on top is on now. See the sensor up here now? The red one on top, right there. So it's on, so it goes up. It's not guaranteed to come up. Well, sometimes the sensor gets lifted, that it just loses. It may be up, but the sensor might lose the guard loose. Sometimes that happens. So things can go wrong that way. Maybe a switch off, switch right. Maybe I really got done. Later on, weeks on down the road, it'll turn into problems that you can physically take the food and fix it. We won't do this something where you say what it is, I got some quick. It'll become things where you're going to use connections to fix things. You have to move to use something. So that's, we work towards things like that. And physically, you have to go to make some adjustments. Just the same way and play, it'll get more real as See, the those valves that ELC on, you can tell which one to be the PLC has LED, so every output has an LED, and the output particular one lights up, it's wired to a particular valve, and then it lights up. So there's a lot of troubleshooting in the electric field. We got the schematics. I do use schematics. For station, I give you those tonight, and we'll look at it. But anyway, get the idea. So look on this one. Look at the sensors on this. These are green. These light up green. Just look on this side. On it's a fuel rod cylinder. Those are cylinders got two rods, and fuel rod cylinders are used for stability. You got to move load. You got to move the load. It's got to be nice and stable so you can hire stroke. And it can't allow any twisting on the load. You use a double rod cylinder. Okay. See here, there's two rods. This load out here is absolutely rock solid. You know, see that? It ain't going nowhere. It has to be rock solid to position the block on the valve. See that? But it's very solid. You've got stroke adjustments on the double nut back here that set the stroke on how far it goes. There's a setting here, very raw, with two nuts. And you bring the package and lose it, and you can change that stroke. Well, they set it up originally and trained to do it. They went through a fine-tuning process with the lenses so that it sits perfectly down like that. Right? That may be something at some point I may do this here out of line. So it has to be done on. When you set the stroke right, then the sensor has to be moved perfectly to pick up the magnetic ring in the piston after the position has been decided how far it's got. So all that stuff, it all has to be really tight for it to, give it an end, the lights come on, and then it is the best thing. All right, so it went down. See the right hand? You can see the chain. See that chain there? So it's not the top and that's the bottom. Then it turned the vacuum off. So it turned the vacuum off. See, it does everything in one little step at a time. But these words valves are off. It has to shut the vacuum off before it comes up, or else it will come up and then drop. And there's no thing working. Everything has to be done in order. There you go. Keep stepping. And then you can start stepping that section already. Right, and then put fluid wants to do that, and do it. And if you watch it, it's got a bearing in here. It has a high bearing and a low bearing. You can make it distinguished. But right now, I think I got all the bearings, I believe, on this one. So here you got, this is called a rotary actuator with a gripper. So it's pneumatic, it's air, it's run off of air. It's got a rack and pinion inside of here, so it's got a straight linear gear with teeth on it. And then it runs a rotary thing inside, rack and pinion that runs that arm out there. So it's a cylinder with a rack and pinion inside of it. It does a arm like a robot arm. It's air, runs off air. So it gets over here. On the back side, there are 3 sensors in here. The arm has a forward, a mid-stroke, and then the track is like that. So there's 3 sensors on the back of this thing that tells you where it is. Okay? The gripper is a little quick. The gripper came on, and it expands in the inner of the bearing to grab it from the inside. Then it's going to come up like that. It come on. You notice the valve kicking on. You're going to get into the, I'll give you a diagram, the schematic that shows the coils for these valves. It's going to show all the outputs where they go to the valve. It'll show all the inputs. I'll give you a schematic right for this thing. We'll begin to look at it, how to read the symbols for the button, the sensor knob. You start getting into that tonight. Go ahead. So that went forward, grip, that went back. Right. And if you're looking back in here, you're going to see that change in the back, the change in your percent. See that? Now you let go of the bearing. Right? Well, actually, there's a pin, a center pin down at the bottom of it, like a thumb that goes up in the hole. A center pin, you pull it pops up in the bearing, and then it lets go of the bearing. So there's a locator that pops up, and then it lets go of the bearing. That's a little short cylinder down in there. It's a little shorty in there that does the location before it lets go. It gives you something to land on. Okay. And then we didn't measure the bearing. That's it's a linear potentiometer. It's kind of like a speed pot. It's a resistor. It's an analog sensor that has, it actually reads the frequency. It puts out a 0 to 10 volt analog signal. There's an input card here. It's an analog input card to be 0 to 10 volt. And when that stem is fully extended, it's 0 volts. When it's fully retracted, it's 10 volts. It'll read any infinite number in their analog to get a measurement, and it converts DC voltage into a measurement in the program. So we can measure there. And it knows if it's a short bearing or tall. It knows. So it's doing a calculation now. And this is your measurement elevator. It shoots up and down. You've got a sensor here on the bottom end, there's the one up top. You notice that. See those two? So this system is loaded with magnetic resistance. It is packed. It is packed. Okay? And this thing here is called a rotating linear actuator. So it has a swing arm that's rotary, it's pneumatic, it's got sensors here, it knows in the 180 degrees, it knows where it is. In that swing, it knows here. And then the up and down is linear. So it knows the linear by these two. This is an inexpensive way to do a robot function. It's fast, clean, cheap. And you did not have to program a robot. It's very repeatable. And you can set your strokes of this thing. These stroke limiters here. And up and down wise, you can loosen this up. That clamp, you can change where it is on the clamp. And that'll change where you're going to that way. Here I'm not moving the camera around like I need to. go ahead. Yeah. Now, Gil, if you're listening, you just need to hurry up and get back. Hurry up. Right, and the gripper open, yep. Yep. The pin went down, yep. And you see the top of the lid, so it knows that the linear part is up. You see that? That's how it knows. It knows this one actuator deal has got up, down, rotary, and gripper. All of that's going on in that. What happened on it? Okay. Swung around, look at here. See, it changed from this to this. Notice that? So it knows where it's at. That go here. There you go. Yep. Good. Go ahead and tap it on. And so look, home position is here. You notice that? That's home. So home means different things. You know, I might think home will be back here, but it isn't. The way the guy programs it, he's got, that's what home is back. This is part of kind of getting to know the machines, knowing when it finishes, where does everything end up like that? You know, in the future, we can have problems where it's supposed to be. Okay. So you want to run that one? The next one is the press. We'll go ahead and go through and do a step through, and then I can start giving you some diagrams on station 1. Okay. So you got another rotary actuator with grippers, and you'll have a vacuum that'll pop on. You hear the vacuum come on? Okay. So it does that, and it's going to bring it on around. Good. You notice 99% of what's in here is all run on air. It's real clean. It's a good way to do it if it's not a really heavy thing that it's got to do. Okay, go ahead. Yep, we'll turn the vacuum on. And here you've got a safety gate here. So here you got a hydraulic. This is actually a hydraulic press here. It's got a safety gate in there. It's got a magnetic sensor over here. And so it knows that the gate's up. When the gate is up, the press will not run. It won't run. That press won't run. Whenever you come around to look, that magnet has to engage with a sensor here. And that sensor, when it engages, it turns on a safety relay. This down there. We cut this here off. I need diagrams. You get diagrams, all this stuff, go with the diagram. This is magnetic sensor that picks up here, and that comes on a safety relay. Safety relay allows the ELC to turn the pump off to bring press back. The PLC tells, even if this goes down, and that resistance, the PLC still tells the silicone to come down. The safety relay is good condition for the pump to come on here in one. So the pump has to be on by way of piston thing, and the PLC tells the silicone to bring the silver back. You know what I'm saying? To bring the hydraulic back, bring the hydraulic silicone. So the pump knows based on this thing back. And when the PLC, that's time when the PLC tells the hydraulic back around here running around. So each day we're going to go through in detail. We need to read the schematics and understand, how to place the wire up, and how to read the line. There's probably so here, this is a station. It's using 2 cylinders. One goes out and then it goes to it move at the same time. So that it doesn't really say that block. Brings them together, so that's kind of I've never seen it done that way, but it's a slightly loose one, because there's no way that swing's gonna happen. Okay. If it came down, say you could lay down, a lot of stuff happened with quicker, it didn't happen. So let's wait for the next step. So it came out the main beginning, and then they both come to, that's one thing to look at when you see what you got right there. So everything, most things have the right color. Most things do. Even if the right color doesn't give you true, it's simulated for your student. If I go there and look at switch, it might disconnect between you. That's kind of stuff that's in the top of it. So it's not. There's things that can happen where it looks fine, but maybe the signal will be get all the way down. And that's where you come in with the you can't really do that. You can do that. You just do that. It's fine. You can hear the back on. We can make it reject certain aspects from the outline. Right now, I'm going to go this way. But it goes through the text. This goes in the paragraph, it's stacked upside down. If it is, this way it comes down, it doesn't flip and sit back. It'll look correct with the palm. And this will make it a no. This will make it a flag transit. This will be both extension, faster extension. And then those are leads, what kind of material it is. Kind of easier to know what kind of material it is. And whether there's a part missing, I mean, the part like in there, maybe the misfire shoot down here and things like that melt. So we would notify how to be clear. And I'll be able to give you the file here. That's the kind of extension this has. Get a little vacuum cutter here, set the vacuum cutter against the front back. A little grease, you can give it on the vacuum. It happens to be the big surface, electric retail surface one. When it gets to here, reject one, just in here, goes out, back, pulls the sheet down, right? And you've got to set them up to different parts. We'll do that. I'll tell you what kind of part of the wall, you step this up a certain area, this a certain area, that a certain area. And if it's selected, you get it up wall, you'll use it with it. When you follow it out and put it in, you have a time spot. I can go to like this section here, I'll go. That's it's really good. That one, just numbers that has specific prime numbers and aluminum. We have a white round one, a white round one, we have a aluminum. In the east material, we have a lot of high things. The 6 primes and flaps, you get those those guys on, if it brings cover in, it's not that possible out there. It brings the company around. It's down here, this is piece of metal. That piece of metal is flat. This is so little thing, people recognize color. If you know that this is white color, dark color, choose to leave that in the back pocket of plastic. And it knows that this is white color dark by reflecting this off of the color. It's photo metric. This is an engineering code that measures the things. So it's very not measured by different layer. It's actually like this is it's going to be the stills. The stills that have been cooked in the this table feels an analog on the field that where it's still needs. You can very much feel like this is enough. So if you fail, if you carry the time, so you have material recognition, color, and time. If it's all that figured out, big things to there, there's a sheet like this, you get a certain amount of money, so a certain figure, you ask for a $1 big bill, whatever. If those, the chicken spinach, that's all the same price. So if it's just went to $55 price, this keeps going. Yeah, these are traditional, this one may be outside of the wood. It's not that way I have them all, and it's going to be a place to stay with it. If you go to the bathroom, come back, and you get no hair, I'll get all my whole thing. Here is the stance screw. It's two bigger stuff. We still set it up. Off the same valve. Here's what we do. There's one of the options. So when one of them is expanded, the other one is back. So the three cylinders in the air lines that we flip up on. How are we going to be opposite? So the one happening is the volume releases the top of the cases of that screw. It lets the bottom drop. And it gives it there's some stacks all on the bottom at the same time. You understand it on the front. And here you've got a black rock extension that goes to the top of the bottom. And there's a red fiber rock plastic that goes through this rock. It shines through it and it gets through the other one. If the light gets through it, it knows it goes through it. ELC said, I think about screwing this kind of moving off. Sometimes when it gets higher, it goes off. You get off. You see, when you see it from that fix, you got the river there. Safety factor, which is safety.
And that's a little river thing, it's fucking little bitty thing. That's what I'm trying to do. And see what we're finding there? That's my rock. Mine is actually going through the rock, so they got transmitting the receiving mode there, so it knows. The module here knows, like you feel it knows that now there's no production. It's got percent. So it reads, when we get to this stage, when we get the data sheet on my monitor, the switch positions, how you program that, set it up for like it's ready to the architect. So this thing is like how many of you have a garage door that goes down with center. So if our garage door, we've got transmit receive. Follow it out. So if you step in there like that, it's the same thing that's true thing. That's happening because the food is moving. So this is works like it works like a garage door center. Once this thing turns, it's got, I've never seen anything like this, but it's returned. It's raises it, it turns. But as a state, you got lots on that stuff. No loss points that we go to the site. See through the most important thing, got you go. Use your points. Yes, you see, they can be actually when it's the right thing you could wear. That will run down one of the they kind of take a big portion of the world market out of the action. You get a good file section of pharmaceuticals, the new products is the way to go to the right point. You notice it's very limited. But big all on one place, got Cleveland, the process plant, they need much of this as they can. Last thing is when the power stop, when you follow, you don't step. If you fail to get it in, it's not easy, then you look at the next one. The ELC is programmed so that the ability to go all the way in and go to the top. So you get the perspective, so you can get it with the pressure. It's on purpose so you don't have to use the it's just set up so that you can manually get it through the woods. This is just for learning purposes. It's not a product you can turn loose to somebody. But you know what I mean? It's save time by it. time that way, the manual gives people all the. It's also a time. It's a time. It's still a time. It's a time where they program the time. They put the timer back so that it does clock time. So you deal with all these things. It's just, our goal is to become a troubleshooter and recycle parts that need to be easily and easily go in and get parts. To me, this is set up like what's going on. Their goal was to put a lot of variety of technology into this thing. For you to learn how to troubleshoot, so you get a variety of skills, troubleshooting. In a small package like that, you actually do a lot. You get into the aspect of the meter and the last drop. You look at this process. There's a lot of and we can't restrict the and we get so good at it. If we feel surprised yourself, you'll be satisfied. If you can go in and work the process, and you find that you find and you find it. We'll do good on this. This is good this year and when you're allowed to do this, you get into it and succeed. I know I've got a place to hold it, they're planning to form and help people with troubleshoot things. And I never just think we're surprised, but I can find problems with everything based on stuff that you do on it. You will do the same thing. So it is time to go. So what we do is we'll start like we need to let this pass further there for station one. We'll start looking at how to read, send, push button, switch. Second class, we're going to do our first lap over there. We'll do the left lap here. We'll step out through. We'll take one on in and go back to the back. It's a good, very good course. Let's get our switches. Cut our switches out. Don't have to be It's the same sentence that you later. If you basically this one, there's two things that are there, one thing. Now you read the I don't think Somebody followed so they get it in. Somebody must know whether.
Well, I didn't do too good on the, I didn't move this around, man, I swear.
That the driver you got? I remember you had.
That's the same one. That's not the movie. That's four. That's like four. The newer one I've got, it's not in here.
You try to work that yet?
I never did try to work this out there. With the mom pants and everything.
I was messing around when it did.
I had back surgery, and my mom had all that stuff had to be cooked. It's just it put me in a whole different mode, and I didn't do much school stuff at all. I thought almost just everything changed real quick. But I've got the drive. I actually took it home. I still got it home. I've got my username and stuff printed out on the paper, got all that stuff ready. I got a motor that sits behind. It's a single phase input VFD to the pre-phase out. Like 12 at home. I mean, I had that one. I just brought it back today. I was teaching on that one on Zoom. I just took it back up. But yeah, I'll work with the workbench thing. So, but y'all, are you saying that people are now they're programming machines and they're not even using 2D files?
Well, the only one that I've seen is like for the iTrink and iTunes, for example, put that on the product, which is weird. But like I said, I got the laptop. I forgot to bring it in, but I'll bring it Thursday.
So is that free software? Is that what it is? Is it free? Nobody uses it?
Well, no, that workbench you have to get it from Rockwell too.
That's not free.
And I have to. Oh, I forgot. Maybe you can help me. I have to download version 29. I got the product here.
Just got the 29 dollars, you got that exact part there for it. This is 21 dollars.
My laptop has got 21.03, it's almost 32. It's got, you got to have the same, whatever firmware is on, you basically reflash firmware.
I just want to see how you troubleshoot here. Maybe there's a better way to troubleshoot, look for stuff. Because I know when the PLC falls out, that's easy, but I know the PLC falls out, you go to the controller and actually see the fault. I don't want to get like into detail on the head or the card itself.
Right.
Like the process. I know when, like, in a glitch in the system, you know, like something's off, maybe a timer or check or sensor, stuff like that. I know that when it faults out, you can go to the controller and look at the fault, or actually the PLC itself, or the card, like you said. You can actually click on the card and it shows you like a diagnostic or the hardware. But I want to learn the process, how to navigate. Like if I want to look for a specific thing, you know, studio it's not like 500 that you can go to the internet and have to studio. You have to look all the way to the left and look for what you want.
You get good at it. Each one of these has got a big program in there, with a lot of subroutines and stuff. You get good at it. You get real good at it.
Are there ways we get into the schematics of the materials?
Yeah.
You must be talking to the right person.
What's that?
Yeah.
I say you must be talking to the right person when you get them into those kind of stuff.
Right. What he's doing, say.
I'm working on day shift, I'm working on field stuff. I'm not a Christian.
You have any kitchen out? I think he started with us a little bit, really.
Yeah.
Yeah, I remember, I remember when something, hey, that's all.
Throw me in the fire.
Well, you showed enough indication, you got to show some action, because you got some capacity to do this, or they will never let you cut.
Yeah.
You know, you got to show some indication, you got to hit for it. And then they'll give you a little bit of rope. They'll kind of give you a little bit of rope to move around. And then if they see you do pretty good, they'll cut you some more slack. They'll let you have some more room. Next thing you know, man, they should do it. Hurry up. Hurry up. How much longer?
So what's your main goal?
You're killing me.
What's your main goal whenever you finish learning?
Well, I'm never going to finish learning.
No, you won't.
No, but
You won't.
But
They
there's
keep
like
changing
the
stuff.
main job that you're thinking of, reaching all the, knowledge that you get.
For me, I just want to be that guy. Maybe I won't be, but I just want to be that guy, and I don't need nobody.
You can do it.
Is there, you're talking about like a technician that go down there with the laptop?
Pretty much, yeah.
They want to be the security guy that everybody comes.
I just want to be. I want to depend on myself. I don't like depending on people. Yeah. Maybe I will one day.
But you still end up with problems to where you have to call.
You're gonna have to go to someone.
Yeah, but like on simple stuff, like I don't want to.
Simple stuff you should be fine. That's I like the notebook, man. That's good that they get writing and stuff, man. Your stuff's gonna be good.
Yeah. That's good.
Sheffield, I think that's the thing to get right there.
100% of liking it. Yeah,
Maybe I'm thinking for it, man.
no, I see kind of start where, what exactly I want to look. You know, this right here, it gives you a little bit of everything. Well, then, electricity, ground, all that stuff, and just, you know.
I like doing on maintenance, like just like maintenance, regular maintenance. But when they gave me a chance, I wanted to go like deep into electrical because everything that you do is driven by electrical.
You see, I know it's not exactly the same thing, but nowadays electricity is on everything. You see, now we got electric cars. Now they're busy with Tesla and neon. They don't know.
He's the richest man in the world. Tesla guy.
No, I ain't not the richest.
I'm gonna say something here to close this out.
Right.
McGill, I am sorry, buddy, that I didn't move this camera around, man. I apologize. I forgot to move the camera around, buddy, so I'm sorry about that. I should have been moving it around, man, for him. I forgot.
Yeah,
Obadiah, he ain't watching. He's going to watch the recording. But the recording ain't going to be worth much at all because I didn't move the camera around. I had to just tell him it ain't even going to be worth watching much for him. Because I didn't put it up where we were. If I had, man, it'd have been fine, you know, but I didn't.
and I was thinking of it.
I can't.
Because if you notice, your desk was always all the way down there, and I tried to move it, but then I figured out this is many people around.
I can't forget.
I'm gonna have to be like.
I can't forget.
Where you working?
Anyway,
at now?
McGill, sorry about that, buddy. I'll do better Thursday on moving this camera around.
Cabinets,
And
custom
we'll see you later.
cabinets.
And have a nice evening, buddy. God bless you.